Hear me clearly? Yes. So thank you everyone. So we are live on Zoom as well as other platforms. Can anyone confirm me if you can see me on LinkedIn as well as YouTube and Twitter as well? And then we can get started. So just put one if you guys can hear me on the chat clearly. I can see a lot of familiar faces. Barry, Samia, Shiv, Shambhavi. Just put a one if you can hear me clearly. And then we will start. So thank you everyone for joining the Career Talk. We will directly dive in. We are a lot of people are there on LinkedIn and YouTube. They are looking at us as well. So thank you everyone. There are few ground rules before we can start. Just put a one if you all can hear me clearly, and if there is any issues on LinkedIn as well, let me know, and then I can take it further. So some house rules for the people who are present on our platform on Zoom. Uh, if possible, just switch on your cameras. That will be great. Cameras on. Mics will be on mute by default. You can interact with me on the chat, and I recommend people whoever are joining on the chat, please be a little bit interactive. So I'm also able to contribute more. If you want to ask questions, please ask the questions on the Slido link. I will be sharing the Slido link on the platform, on our Zoom chat as well as on LinkedIn, YouTube, and then take it further. So this is what we are going to do. So for everyone on the chat, this is also a part of the call that we are having about the challenge. Just put one if you guys are part of this challenge that we are starting on Saturday. So looking forward for this excitement. And I hope all of you have completed your day zero. If you have not yet done it, I have shared the link on the chat as well. It is complimentary for some time. So please take this opportunity to join this challenge. And if you have any questions about the challenge, please put it on the Slido link and I will take it at the end of the call. Right now, let me go through the topic of the day and then we will take it at the end of the call. And this is something that all of you think about the app that you are building, and please put it on Saturday. On Friday morning, we'll be starting the day one. Please be prepared for having that. Amazing. Thank you everyone for confirming. And now we have been doing a lot of sessions lately on statistics. Today is our third follow-up session. If you guys have not seen the first two sessions, please look at that workshop recordings, because today is the third session that we are doing. First, we started with basic statistics about mean, median, then we moved a little bit into statistical deviation and all those things. And today, we are going to talk about probability. Just put one in the chat if you know about probability or you have studied or learned about probability in the last few years. So thank you, Mr. Ahmed, on LinkedIn for mentioning. Yes, this is a very people are very scared of this topic. People are very scared of probability. But do you guys know the chat GPT that we are using is based upon probability? Everyone wants to build their own chat GPT, but no one wants to learn the fundamental principles of probability. So if I had a session with AI agents on the Career Talk today, then we would have 30 to 40 people joining the live Zoom call. Everyone wants to learn AI agents, but today's topic, world of probability, very few people have joined the call. But all of you who have joined the call and listening to us on LinkedIn, you guys are going to make the difference because you are giving value to the foundations. Because tools will come and change, but these foundations will always be there. So a lot of people know about probability. So thank you for confirming. So and today I'm going to talk about this. Today I'm going to go deeper into the probability, and it's very important to know. Even if you are not going to be, we are not going to go to the mathematics part of it, but we need to understand how it is working. So just put one if all of you are excited to go into the world of probability. And this is actually a part of our essential prerequisites of our AI residency program. So this time in our AI residency, other than Python, I have also included statistics as a prerequisite, because no, everyone wants to learn about agents, about all the new technologies. But if I ask them something about statistics, they are haywire. They are confused. Even though you have studied this in school, you forget it, and you are scared of probability. Like today's session, I expected more than 30 to 40 people to join, but very few have joined in single digits. But on LinkedIn, I have hundreds of people watching. So thank you everyone for showing your seriousness and taking it further. So now coming to the most important part. I will deep dive into the slides that are there. And if you have any questions, let me share everyone in the chat. Give me a couple of seconds for your questions. I'm already started getting questions, but I request you to put your questions on the chat, and me and the team are going to answer all your questions. So don't worry till the all your questions are not answered. We are going to be there. So let me just put this as well on the LinkedIn, and some of you can support me to look at YouTube as well. And yes, if there are any questions, please put it there. Now, coming to the most important part of probability, uh, can anyone tell me the definition of probability in the chat? Any one of you who can you tell me the definition of probability in the chat? Amazing, amazing. So probability, yes, thank you, Ahmad, for confirming. It is outcome by total number of, yeah, this is the way of telling it. I will go a little bit details, but what you said is correct. The possible outcomes by the total outcomes that are there. So that is what is probability. So that, thank you for that. Now let me, can you just tell one if you can see my screen? Just give a one if all of you can see my screen. So thank you, Ahmed, for confirming. So today we are going to deep dive into the fundamentals of probability. This is one of the most boring topics, and whenever I tell my AI residents about probability, they run away. But this is a very, very important topic. I have already talked in a couple of sessions about it. But today I want to talk about details about this, and your goal is figure to how to put a number on the uncertainty and make predictions, and then test those predictions using code. And that is the reason why I am saying that please don't worry about the formulas. We are going to use Python code to understand their numbers. So you don't need to memorize any formulas. That is a good part about learning probability in the age of Python code that is there. Amazing. So now we are constantly surrounded by randomness. Like questions like, will it rain tomorrow? Will our favorite team win? Probability is really amazing mathematical tool that lets us exactly measure and predict all these uncertainties. And this, it brings a sense of order to what often feels like a very, very random event. So everything that happens in the world happens because of some specific thing, and probability gives us some numbers to think about. Right. And today, what we are going to do, what is our game plan going to be, is we will start by defining what is a probability. Then we will move through its essential building blocks and rules. And like Ahmad in the chat has mentioned the definition of probability, but we will try to make it as simple as possible. See how new information changes our calculation where conditional probability comes into the picture. Bayes theorem is something that people are scared about. We will try to debug it with a very simple way, and then if time permits, we will try to do some Python code simulation. But all these things that I'm telling is part of our AI residency. So you will be getting all the code, PowerPoint, recordings, everything in details there as well. So now someone mentioned what is a probability, but at the core, what is probability? Can anyone also put in the Zoom chat as well? It is the best method of putting a number on a chance, and it boils down to a number between 0 and 1. And if the probability is 0, the event is totally impossible. And if the probability is 1 or close to 1, it is sure thing or absolutely certain. And this is life's uncertainty falls somewhere in between 0 and 1. So this is the main concept of probability. We will go a little bit deeper in the next slides, but think of a probability like a long run frequency. One very, very simple example is flipping a coin, and we will go deeper into that as well. But to understand probability, you want all of you understood the definition. Just put one if all of you understood the definition of probability. And now to go deeper into probability, thank you for confirming. Thank you, Ahmed, thank you everyone on LinkedIn for confirming. LinkedIn is more active than Zoom chat. So I request people to be interactive on chat so that I know that you guys are listening to me and not getting bored. This is a very boring topic. I'm trying to make it as interesting as possible. So two building blocks that are very, very important. We must learn to speak its language by understanding these blocks that are there. The first thing that it is called random experiment. So what is a random experiment? Anyone in the chat, can you put? This is a process where you don't know the result for sure. Simple examples are like including a rolling a dice. When you roll a die, you're not sure whether you're going to get a 1 or a 6. Flipping a coin, you're not sure whether you're going to get a heads or a tails. Or pulling a card from a deck. You act, but you can't predict the exact outcome beforehand. Just put one in the chat if everyone is clear with random experiments. Barry, anything. Now I need to call out names. So Mazin, Samia, Sara. Just put a one if everyone is clear. Shamvi, Shravanan. Shravanan is a part of our AI residency. So you are getting the idea of what is an AI, what is a random experiment, right? So random experiment, we don't know what is the outcome. Now the second thing that is there is very, very important is our sample space. What is a sample space? This is a fancy way of saying the complete list of every possible thing that could happen. It is the entire universe of a possibility. So suppose if I flip a coin, can anyone tell me what is the sample space? Amazing. The sample space is my heads or my tails. So that is our sample space in this scenario. Or if I am able to uh, throw a die, then I have six sample space. That is 1, 2, 6. So that is our sample space. Now this is the most important thing, the event. So the event is the specific outcome or a group of outcome that we actually want to measure. It is one piece of that bigger sample space that we care about. Example one, the two, in if we do a die, or the head or the tail if we are throwing the flipping the coin. Now I will just repeat the three most important building blocks that are there. One is random experiment, sample space, and event. So in every type of probability, these things are very, very important and it comes into the mind. Now we come to this random experiment. If we are rolling a die, the sample space is, can anyone tell me when we are rolling a die, what will be the sample space? Amazing, amazing. Thank you for confirming, Mr. Ahmed. One, two, three, four, five, six. And the specific event we might be interested is, suppose rolling an even number. So suppose I am throwing a die. What is the probability that I will get an even number? Can anyone tell in the chat? So if I am rolling a die, what is the probability that I will get an even number? Amazing, amazing. It is going to be 50% because the even numbers are 2, 4, and 6, and the other numbers are 1, 2, 3, 4, 5, 6, which are odd. So this is the subset, the event that we are going to expect, that is 2, 4, 6, and the sample space is 1, 2, 3, 4, 5, 6. So thank you everyone for confirming. These are, again, we are going back to the foundations that we have studied in higher school, which is very, very important, which most of us have forgot. Now we need a toolkit. We need the rules that allow us to combine this probability that we have discussed and solve some complex problems that we have understood. We understood the building blocks. Now we will take it one step further. There, first, to understand the type of events, there are two very important types of events every one of you should know. One is, it should be a mutually exclusive event. Mutually exclusive events are very, very simple, right? These events simply cannot happen at the same time. Suppose you cannot roll, when you're rolling a die, you cannot roll both a 1 and a 6 with a single die roll. There is actually one or the another. So this type of event in the first one that you are seeing is a mutually exclusive event. But an example of an independent event that you are seeing on the right side is they have a zero effect on each other. getting a heads on your first flip does not change the chance of getting the heads on the second flip. So these two types of events are very, very important. You will hear this every time. Mutually exclusive events and independent events that we are talking about. So this is something that we need to understand. This example is the core rule that you need to know. The event type tells you exactly which rule to use. First is the additional rule. Helps find the probability of event A or B happening, like rolling a 1 or a 6. So that is the additional rule. Then we have the multiplication rule. It is used when you want the probability of A and B happening, like flipping a head twice in a row. This is something that A and B, this is the multiplication rule that comes to the place. And the third and the most important core rule is complement rule, a handy shortcut to find the probability of something not happening. So this is the concept of core rules for these type of events. Just put one if every one of you are clear about this, and if you have any questions, again put it on Slido, and then we will try to take it and solve this problem. So I have tried to define everything in a very simple language so all of us are understanding. Probability isn't set in stone. It is a very, very dynamic tool that we have to actually update when the content changes. So probability is not something very static, and it is not set in the stone as mentioned. This is where things get really interesting. So what we have studied earlier is very simple use cases, understanding the building block. Now we will take these learnings and put it one step further, where we are going deeper into the dynamic thing that is there. So this is something that everyone gets scared of. Conditional probability. Can anyone put one in the chat if you know about conditional probability, and zero if you don't know about conditional probability? I can see a lot of familiar faces on LinkedIn, so thank you for all your comments and support. Hope you're enjoying one of the most boring and scared topics and neglected topics in the world of statistics, data science, and AI. So thank you for that. Yes, so a lot of people know about conditional probability, but I will just try to summarize it. This concepts answer the question, what is the probability of A happening now that I know for a fact that B has already happened? It is written as P A dash B. That little vertical is, let me just write it for you. This is something like this P, then we have A, this vertical line. This is the thing. This vertical line means given that, and it signals that the whole game has changed. So this is the probability, conditional probability that is very, very interesting. We look at an example here, very interesting example. The chance, okay, how many of you play cards here in this room? So when you have played cards, you will understand this better, but I'll try to give an example. There are 52 cards. So the chance of drawing an ace from a full deck of cards is 4 by 52. Everyone just put a 1 if everyone is clear about this. The chance of drawing an A in a deck of 52 cards is 4 by 52. This is a simple probability, but now I change the game. I add one extra layer. But what if I tell you that the card you drew is red? So now I am putting one more condition, that the card you drew should be red. So now if you know that there are 26 red cards and 26 black cards. So our sample space that was there, now it shrinks from 52 to only 26 cards. And in that new small world, there are only two red aces. So the probability instantly updates from to 2 by 26, and that is the power of a new information. So I told every one of you in this call how a simple thing happens. So it is going to be 2 by 26, not this thing, because here the 2 and then also the total sample also has changed. I hope now it is clear. It is going to be 2 by 26. Just put 1 if everyone is clear by this simple conditional probability example. So thank you everyone for confirming. Thank you, thank you. And hope this example, are you guys enjoying the probability? Just put 1 if you're enjoying learning probability in a very example driven way and not formula and maths driven way. Says. Amazing. Thank you for confirming, everyone. And now moving to this is the Bayes theorem. This is an additional built upon conditional theorem that we were discussing, and I want to talk more about this. This is a formal way to handle this updating that is happening. It starts with an initial belief, example, the general chance of a disease, and takes in the new evidence like a positive test results to give a much more accurate, updated probability. And this is very, very critical in medical diagnosis or AI spam filter or any specific thing. So I will just repeat, we start with a belief, initial belief, and then take in the new evidence to give a much more accurate updated probability. And this is how Bayes theorems comes into the picture. Now all this theory is great, but how do we know it actually works in the real world? We can use code to run our experiment, a quick experiment, and see what is going to happen. So this is a very good example that when especially in probability, this relies on a core concept called the law of large numbers. So I will just give you an example. Suppose I am flipping a coin. What is the probability that I will get heads? So thank you for confirming, Vaisakhi, Aves. Yes, it is 50%. So if I flip one coin, I will get 50%. Now you tell me, if you repeat this experiment a ton of times, 1,000 times, the result you get will incredibly be close to the theoretical probability that you expect, which is anyone in the chat? If I'm going to flip this same coin 1,000 times, what is the probability in out of that 1,000 times? How many heads will I get and how many tails will I get? So this is very, very important. That end of the day, if you run the code, you will see that you will see very approximate to 50%. So this is the law of large numbers, and the theoretical probability of the heads that I was mentioning you is 50%. And even if you run a simulation using a Python script to flip a virtual coin 10,000 times or more, or then you will be getting something very, very close to 50%. So this is the way you do some simulation in Python language. We have the whole notebook in our AI residency where people can experiment with this and take it further. And I will, maybe if I get time, I will show you as well. So your Python simulation of 10,000 plus coins or more will show that you get very, very, very much close to uh, the actual result was approximately 4,981 heads, which yielded a frequency of 0.4981, which is very, very close to zero point 0.5 if I round it up. And this demonstrates the law of large numbers in actions and proves that this maths isn't just abstract, it describes how the world works. This is true to everything. So some of you are asking, why is it important? This is the fundamental blocks of AI. So if you don't understand probability, you just are using AI. And the purpose of decoding data science is to you to understand the core concepts. And that is the reason why we have a lot of importance to these topics. And I hope you guys are understanding and pay some more attention to this topic. So quick recap that we want all of you to have is we have gone from a very, very basic definition to running a virtual experiment and showing you the results. And the takeaway of this particular part is probability measures uncertainty on 0 to 1 scale. So the probability can never be more than 1. It always starts from 0 and it ends at 1. We learned the key building blocks. What are the three building blocks? Can anyone put in the chat that we have discussed? So it is going to be like a reminder. People on LinkedIn and on Zoom, what were the three important building blocks that we discussed before we went into the more uh, advanced topics? Yes, thank you for confirming. Thank you. Thanks a lot, Ahmed. Experiments. First one was experiments, random experiments, sample spaces, and events. And we covered these core rules of combining the probability A or B. A and B. All of you remember that. And crucially, we saw how conditional probabilities and Bayes theorem lets us update our knowledge when we get new data. So thank you everyone. Now probability is everywhere. Like today's when I gave today's session, I wanted you to have the thinking cap open. Whenever you talk about weather forecast to stock market or to your favorite sports, think probability. And now that you have got the tools where in your life you start to spot these hidden patterns that are there and understand what is happening, question these things that are happening. So now what I'm going to do before I move to the next section, I am going to go to the Q&A part and then take it further. So let me share my question sheet with all of you. If you I can see there are some questions that are coming in on our chat. So let me ask everyone to put the questions on the Slido, people who are on LinkedIn and on the Zoom chat. So there are some questions regarding the challenge that is coming in. So the first question regarding the challenge is when is this challenge starting? So the challenge is actually starting, as I mentioned, it is starting on the Saturday, this coming Friday, not Saturday, this coming Friday. But the day zero has already started. The day zero has already started. So I recommend all of you to start going and putting in your details, downloading the information, thinking about what you want to build, use any no code, low code things that are there and take it further. So this is about the challenge. Regarding the age limit of the challenge, yes, if you want to be considered in the finalist, you need to be 18 plus, but you are free to join the challenge and learn and do the submission. But for the prizes, you need to be 18 plus. So that challenges, these are some of the questions of the challenge. Now there is a question about the AI residency. The AI residency was supposed to start, the live classes were supposed to start on 8, but we have pushed it for 2 weeks. But we are doing the prerequisite classes of statistics. So today is the third class that we are doing continuously for statistics. We will be continuing a little bit more and we will be continuing the series. So we want people to learn about these skills, about probability and all those things that are there and take it further. So now coming to the next conference. So the next conference, there are a lot of conferences that are happening. Function one is the next conference that we are happening. Then we have our low code, no code summit. So every week there are events and conferences that are happening, and we are part of most of the events that are there. One person is asking in the chat, this is a question that someone asked in the chat as well, that what is the difference between correlation and causation? So the difference between a correlation and a causation is we will be going a little bit into detail, but I can just tell you one example. I've created a video on this as well. So correlation is like if I tell this statement, right? There was a increase in ice cream there was an increase in the sales of an ice cream, and and there was an increase in the number of drowning cases. So is if I tell this sentence, you will not know that there may be a correlation in these 2 points, but you will not know this is actually happening. There is a hidden factor on this. Can anyone tell me what is the hidden factor on the increase of ice cream sales and the increase of the drowning? There is a hidden factor that is there. So correlation can tell you the numbers, but it will not tell you the details. So the relationship is the summer, the heat. When the heat happens, what happens actually? The ice cream sales also increase. The number of people going to the beach also increases, and the number of drowning increases. So you need to find these. You need to find the hidden factors in correlation. Causation is very direct. Suppose I increase the number of ad spend, and in a very set behavior, set environment, I know that if I put $100 on ads, I will get some conversions. So that is causation, which is very, very direct, and we know the reasons. So I hope all of you are able to understand this question. Now let me take one more question and then we will move to the next slide that is there. Yes, so AI residency, there's a question about AI residency. Let me just make it 3 more minutes. So when is as I mentioned you, the AI residency was supposed to start on the 8th November. We don't have that many students, confirmed students. So that is the reason why we have pushed it for some time and we are doing the essential prerequisite this thing. So because this was this particular month, all of you know, was there were a lot of events, there were a lot of activities that were happening. So I personally, the team could not get time in doing interviews and getting people on board. We have hundreds of people who have shown interest, but we could not get back and do interviews and finalize the students, because we select very specific students who have the willingness to learn. We don't admit everyone. We interview them, we see their caliber, we see how much minimum experience they have, how much they can contribute, how much they can learn. So this is not a program you pay money and you join. There is a selection process that we go through, and we only give the link to the people who we feel are can give some value and can learn with us. And because this is not a school where we teach you eight ABCD, we give you the building blocks, we give you ways how to do things, we give you a lot of recordings and the direction, and then you take it further. So this is not a course, this is actually a program where we have access to everything, and we do master classes and workshops like this, and we connect everything together. So this is a very unique program that is there. You can still apply the team will reach out to everyone for an interview, or at least to give a talk about this. So at least to know whether you're interested. Maybe it is you're right now you're not ready for it, but maybe in the future, when you are ready for it, the team will reach out to you, and you can apply every quarter with these two events. Cool. So now coming to the next part that I want to quickly talk about is the distribution part. So let me see if there are any more questions that are there. Regarding the challenge question, yes, there are some questions coming on the challenge that yes, it has started. The day zero has already started. So Barry is here. Barry can help you for any challenge related question. Please join the WhatsApp group. Let me open the challenge page for all of you. So this is the challenge page. There are 28 people right now. Please go here, join the WhatsApp group, everyone. Can you see this WhatsApp group? And go to the leaderboard and go to the feeds, and you can start using this tool. It's a very, very good tool for, collaboration, learning, and come to the WhatsApp group, ask your questions, and learn together. Learn together, try to build something, share your knowledge. This is one of the best ways to learn. And I recommend everyone to at least take part. And the best part, it is free right now. We have complimentary free passes till it becomes 50 people, and then we are going to make it paid. So please join in, take the early opportunity, and take it further. Now the time is up. And now let me go to the next part. Just put one if everyone is clear. Everyone is clear so far. And now we are going to go to the distribution part, which is the boring part that is there. And yes, someone is asking me to show me the code. So this code, as I told you, is a part of our AI residency, but I can show you. If I get some time in the end, I will show you the code as well. Don't worry, because running the code is very easy. You just need to understand the concept and then take it further. Amazing. So let me quickly share my screen, and then we will be taking it further. Cool. So now, yeah, so now let me increase my, just put a one if you can see my screen, everyone. Amazing. Yeah. Thank you. Thank you for confirming. Cool. So have you ever wondered how a weather app predicts a 30% chance of rain, or how Netflix seems to know what exactly to show what you want next, how it personalizes the content? And it all comes down to understanding this randomness that we have discussed in the earlier section. Now we are going into the distribution part. The world is full of uncertainty, this type of uncertainty, from a simple coin flip that we discussed earlier to the complexities of a stock market. And the big question is, how do we find order in all this chaos that we are looking at, and what maths to describe and maybe even predict, and what may happen next? So this is a very, very important concept when we talk about distribution, and which is very people are scared about this. And today we are going to take these big ideas, the random variables and distribution. These are the two most important topics that we are going to take, and turn them from abstract theory into actual tools that we can use, and particularly in the code. First, we will understand the practical use of these things. the random variables and distributions. Can you guys put on the chat one if you have heard about these topics before? These two topics that are there, random variables and distributions. So yeah, thank you for confirming everyone. Yes. And what is our game plan for today is that we are going to define these variables, random variables, look at its blueprint, the distribution, that is, we call it the blueprint, meet the two heavy hitter distribution. There are two heavy type of distributions. Can anyone put in the chat what are these two heavy hitter distributions that I am talking about? So I will be able to know that the guys who are listening and telling, is it important to learn stats, know about this? Can anyone tell on LinkedIn what are the two heavy hitter distributions or the two main distributions that I'm going to talk about or is there in this in the world of statistics? Thank you for confirming. Thank you for confirming. Amazing. One is the normal distribution. Thank you, Savanan, for confirming. And the second is the binomial. And then Poisson is the third one for time duration. But right today, we are going to focus mostly on the first two. So everyone, this is very, very important. Normal distribution and binomial distribution. And we will take it further step by step. And then we turn this theory and we'll try to talk about the practical applications. So random variables are very, very important. Uh, we need a way to talk about the random outcomes that are there using a number. And you can't just plug head or tails into an equation. You can use one or zero. So this is something that we will go into details. There are two types that we need to understand in a random variable. First of all, we understand that random variable becomes a numerical quantity whose values depends on the outcome of the random process that we discussed in the previous chapter. So that if you remember, we discussed that, but random variable, it takes the numerical quantity. So this is just put one in the chat if everyone is able to understand the difference between a random process and a random variable. Great. So now, thank you for confirming. So the best way to think of it is a placeholder for a number that we don't know yet. We often call it X, and the actual value of X remains a mystery until the experiment is done. So this is how we start with a random variable. So there are two types mostly. The variables come into two main types. One is the discrete variable, as you can see on the left side. Very simple. The things we can count. One simple example. Can anyone put in the chat an example of a discrete variable that is there? Yes, thank you for confirming. So the number of cars that pass by, you can have 10 or 11, but you cannot never have 10 and half. So number of cars becomes a discrete variable, or the number of heads you get in 10 coin flips. It can never be 3.7 heads. So I've just put one if everyone is clear with discrete variables. Awesome, awesome. Thank you, Mr. Always. Thank you, Ahmed, for confirming. Now, continuous variable. Anyone can give me example of a continuous variable? These are things you measure like height or time, and they can take any value within a range. The exact height of a person, that can be an example, isn't just 6 feet tall. They could be 6.01 or 6.02. So that is a continuous variable. It can take any number that is there. So I hope everyone is clear with these two examples that are there, and then take it further. Amazing, amazing. Thank you for confirming. Now, everyone understood the difference between a discrete and a continuous variable. If there is any questions, please ask in Slido. We will be taking it further. Once we have these variables, how do we know what they are likely to do? Every single random variable follows a kind of a blueprint that describes all its probability. And this is called probability distribution. I will repeat, every single random variable, it follows a kind of a blueprint that describes all its probabilities. And this is called a probability distribution. And this is very, very interesting concept for discrete variables, which is the countable ones that we discussed like number of cars or something, number of heads. The blueprint is called probability mass function. How many of you have heard about this PMF? People get scared of the because before you used to show the formula of PMF, everyone used to get scared. That's why I'm not showing you any formulas in this slide, keeping it very, very, easy to understand and start liking it. Because if you don't like probability, and I will tell you, when I was a student, I hated probability. Believe me or not, 20 years back, when you asked me about probability, I was very scared of it, because before, the way people used to teach was by formulas, and formulas, and I was not happy with formulas. I'm not a formula guy. So for me, it is how I can decode it, how I can make it simple, and how I can teach this to my students and make it fun to learn. Because I hope every one of you are enjoying this lesson. Just tell in the feedback if you're enjoying, or you're getting, is it too heavy, or is it okay? PMF is very, very simple. It assigns a specific probability to each and every possible outcome. A PMF, or a probability mass function, tells you the exact probability of getting 7 heads in 10 flips. And if you do the math, that comes to around 11.7 percentage. So just put 1 if everyone is clear with this concept. Amazing. Thanks for confirming. Now, for continuous variable, it becomes a little confusing. For continuous variable, what happens that we use something called as a probability density function, PDF. This is where things get a little tricky, but it's cool if you understand from this diagram. With a PDF, the height of the curve does not actually tell you the probability. It is not the height, but it is the area under the curve. So you might have heard this topic, area under the curve. A lot of people use it in statistics and machine learning. So the area under the curve for this probability density function between 2 points, that gives you the probability of that interval, and then you add it up, and that is the probability density function. So this is one quick example. For every real PDF or probability density function, it has to follow two basic rules. The first is no negative probability. The curve can never dip below zero. This makes intuitive sense. You can't have a negative chance of something happening. And the rule two is the total area is 1. The total area under the whole curve must add up to exactly 1. This just means there is as exactly 100% chance that the outcome is going to be somewhere on the map. So I will repeat. The first one is no negative probability, and the second one is that the total area should be 1. Just put 1 in the chat if everyone is able to understand these concepts. By the way, the recording, the code, everything will be available for AI residents in the LMS platform. So you don't worry. Please revise these videos. Look at these videos couple of times if you have any questions, and then take it further. So thank you everyone for confirming on LinkedIn and giving a thumbs up, and let me move to the next slide. So now we are going to talk about the two stars that are there about distribution. We call it the most valuable players that you will constantly see in the AI and data science world. And already Shravan mentioned about that. The first is the binomial distribution. This is our first distribution. It is your go-to model for any situation that has only two possible outcomes. Example, success or failure. That's the reason why binomial, that is two. Yes or no, success or failure. In logistic regression also they use these types of things. And what it tracks, it counts the number of successes you get in a fixed number of tries. So this is very, very important. It counts the number of successes that you get in a fixed number of tries. The probability of success must be exactly the same for every single try. Like flipping a coin. It is zero point 0.5 if it is heads, zero point 0.5 if it is tails. So this is going to be there every time when it is successful. And since we are counting successes, so it is a discrete distribution. So this is what binomial does. Just put 1 in the chat if everyone understands this. I will repeat. The probability of success must be exactly the same for every single try. And as we are counting it, counting the success, that's why you can see visually you can see a bar graph here. Now, what is the probability I get exactly 7 heads if I flip a coin 20 times. Or if I can reframe the question, what is the chance we find three defective parts in a new batch of 100? Here, the mean or the expected value of this distribution is calculated as n multiplied by p, and that gives you 11.17, which I have told earlier as well. Our second all-star, before I go to my second all-star, is everything clear? Just put one in the chat if everything is clear. And these are high secondary maths that I am talking about, which is very, very important for all of us to know. The second all-star is, can anyone tell me what is the second all-star that we were discussing on the chat on LinkedIn? If anyone can tell me what you're seeing on the chat, what is it? Yes, thank you for confirming. It is normal distribution. And this is what you see is a famous bell curve, what we also call as a normal distribution. And this distribution is basically royalty when it comes to the continuous data that is there. And if you see the shape, it has a very classic, beautiful, symmetric bell shape that we call. The entire curve is defined by mainly two numbers. Can anyone tell me what are the two main numbers that is defining this beautiful symmetric bell-shaped curve? Yes, thank you very much. The first one is the mean, the central line, and the second one is what we discussed yesterday in our master class is the standard deviation. It also, this beautiful phenomena that I'm talking to you right now, it is called central limit theory, CLT, which suggests that when you add up the bunch of different random things, the results tends to look like this bell curve. And this is a famous empirical rule that we also talk about. And can anyone tell me what is the empirical rule here? If all of you remember, the empirical rule is this one, 68%. This is about 68% of all your data will fall within just one standard deviation of the average. This simple fact is incredibly powerful for making quick guesses. And just a comparison between binomial and normal distribution. Binomial is for counting and looks like a bar, while normal is for measuring and gives us smooth bell curves like we showed in the earlier case. And this is the empirical formula that we have spoken. We have done a simple comparison as well. And now what we are going to do is I will not do the code part right now, but I will be telling you the simple things that we are going to discuss in the notebook I'll be sharing with all the AI residents. You can go through these videos again and try to run the code step by step and take it further. So this is and all the things that I have discussed, you don't need to learn the maths and you don't need to learn the formulas. There is a very good function in NumPy. If you can see the steps that are there, you can load numpy.random to get random variables, and then you can use the function of average mu and the spread sigma to do all the work. And you can I have the code notebook as well to run it. The good thing about all these things, when you run these notebooks that we have in our AI residency, the power isn't just fun coding trick. Once you know how to simulate these distributions, like how to look at continuous, how to look at binomial and all these distributions, you can simulate and you can start model actual real world systems. You can understand these things. You can build simulations for things like customer wait time, daily stock market changes, or product defects. This capability gives you incredible power to forecast and make any smarter decisions that are there. So these are the building blocks of any machine learning technique like linear regression or logistic regression. If you don't know these distributions, you will not be able to do anything. So today's conclusion is we have gone from very abstract maths to understanding how things work. And then next time, if you get access to the Google Colab Notebook in AI residency page, you will know how to run the code as well. You will know how these fundamental building blocks are there to describe this uncertainty and model randomness for yourself. And the only question left is for all of you that what patterns will you uncover and what will you build? I always tell people that whatever data that you see, if you don't understand these distributions and these foundations, you will not be able to make any specific decisions that are there. So we have 7 more minutes for the call. There are a lot of questions that are coming it on the chat. So what I request you, please use the Slido link to put any of your questions, and then we will take it further. So let me give the timer. And we will start the question, and we have, yes. So we have 7 minutes, and then we will take the question. So now coming to the question that is there. Amazing. So some people are asking access for the notebook. As I told you, this access to the notebook is part of the AI residency, and I have a separate course that I have created for this basic stats. So we cannot give you everything for free. If you really want recordings and these type of things, I request you to get access to that, right, and take it further. So because those things are very important. It took a lot of time and effort to create all these things and put these things together. So we will be doing that as well. So please, these calls are there. Attend our community calls, live calls. These are mostly we do couple of calls for free. You can come, you can learn live, you can ask questions. But if you want to go a little bit details, we have academy, we have residency, we have different programs and courses. So you need with a very affordable fee, you can take part and you can get the access to those recordings. So thank you for that as well. There are some questions again coming regarding these concepts that are there. How is it relevant for generative AI? So today's concept that I have told you is one of the building blocks of generative AI. But my main purpose here, I will tell you why I'm doing these recordings, right? Because we have talked a lot about Python, about transformers and all these concepts, but no one understands the difference between correlation and causation. When I tell them binomial distribution, they are lost. But at least now, after today's call, I hope Shravan, Barry, at least you understand what is these topics, right? What is normal distribution? What is the binomial distribution? At least you know these concepts. I don't want you to have a uh, surprising face when people ask you about these topics. And when you are working in the field of AI and data science, people expect you to know about these probabilities and about these distributions, because it is the building block of what you have built. So I hope I answered your question. Any more questions that are coming? There are some questions that are coming about the challenge. So challenge, please join the WhatsApp group. Barry will help you. We will help you, and we will take it further. Yeah. Now coming to one question about the next community event. So next community event that we are going to do is we are going to have one more online session where I am going to go a little bit details into exploratory data analysis. So I'm going to announce it on a Monday or a Tuesday evening, where we'll have the fourth series. Now what we are going to do is whatever we have discussed, we want to take it one step further. So that is what I am going to do. I will be confirming it on the WhatsApp group. So please attend it live. I want to continue the series of statistical thinking. There are a series of up to 5 or 6 workshops, I think, which we are going to do. What is the outcome of this? The final outcome of this again is, guys, you will have a sound understanding and connect everything together and understand how these terminologies work. So what we are going to do is we are going to go deeper. The next session, we are going to talk about exploratory data analysis. So whatever we have learned, maybe we can take it further and understand a little bit, because I've already made you understand about the central limit theorem and all those things that are there. There are few terminologies like confidence interval and hypothesis testing. I maybe talk about this for a couple of maybe the first half, and then I will go to the directly to the exploratory data analysis. But if those terminologies come, I'm sure it is going to come, then I will talk about that as well. So you'll have a very good understanding, and then you can go to the end. So let me quickly share you my screen, everyone. Someone is asking about how to get access to this academy. So let me just share my screen 1 minute, everyone. So once I log into our Academy portal, everyone. So once I log into my Academy portal, once you get access to this, so you will see all our recording of our AI residency, cohort 7, cohort 6, everything is here. And can every one of you just put one if you can see basic stats for ML and AI? Here you will see all the recordings. all the recordings, workshop recordings, as well as this, and the collab notebook that has been used. Every chapter has one collab notebook where we are doing the simulations. So this is what you will be doing and what you will be getting once you have this access. And the second thing is about the challenge. So some people are asking about the challenge. So for the challenge, who are joining for the first time, please go to this website. And as I mentioned you, and please do my progress, do start here. Once you do start, join the WhatsApp group, get the free access to our some support materials, and then make the submission. Just did you download the template? Yes, 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 yes. Whenever you do all this, after you do all this, just do mark as complete. That's it. It'll just take you 10 minutes. Now you are ranked number 29. So, and then just mention here great experience. So please do this. So we get offer option in the thing. So a lot of people are asking in the chat how to access this challenge. As I mentioned you, this challenge is here. Let me also put the challenge in the chat and then take it further. So if there are no more questions, I hope every one of you enjoyed the session. Just keep coming to our community meetups and have a great day, everyone. If there are no more questions, we'll wind up for the day and happy Sunday and see you in the next event.